Welcome to another episode and video on my Arduino Mega2560 connected to breadboard with some electronics and connected with 4 probes to an oscilloscope to measure signals, to detect signals. I started this whole thing by trying to use an inductor to move an object. Well, so far that has absolutely failed. But so previously I programmed the Arduino in C, programming language C. For some episodes now I have changed into Octave, and Octave is a mathematical language and you can capture data. Somewhat different than in C. In another project I also capture data, but this goes different, and I'll show you how if you haven't seen it before. So what are the probes doing? Wiring from pulses modulation to the switch. One probe to detect the original signal. Then here a probe that detects the signal after the switch. The switch is normally open, which means that the circuit is only valid after pressing while pressing the button, not after, while. Then this one is for signaling, so this goes straight to pin 4, which is then detected and captured into an array, a matrix actually, or a vector, but the vector is a one-dimensional matrix. And then this one to capture the voltage in this circuit, which is connected to power. And when I do this, nothing happens yet because I haven't loaded the program. So from Octave to start it, I don't have to load, I have to just run it. So let's do exactly that. And that is actually already working. Also look right here on the oscilloscope, and that is the signal that is working. So let me change the setting of the oscilloscope a bit. That shows much better what's going on. The level I'm not happy with because that doesn't make sense, but it works. So then pressing makes everything work, well, supposed to. A lot of signaling then suddenly on the oscilloscope. And you'll see that when I change to the screencast. So let's see. Oh yeah, right here is clearly 2 LEDs. This LED is always on when the switch is being pressed, and this one is on due to the voltage coming the other way. And that part of the circuit is not fully functioning yet. So let's see how things are working. Alright, so this is the other view from the screencast, and when pressing the switch, watch the oscilloscope image, a lot more to see. Keeps running. So let's go here and press Ctrl C, and then you see things are not going not always going as intended. No surprise. But it should have been better. Oh, I'm not doing a clear all, just seeing if this will work, because there is something else that I had in mind. This is, as you can clearly see, a vector of one dimension, one row, two columns. Usually, when you are talking a table, it's one column, more rows. Well, here it is quite easy to do. Change change 1 into 2, change 2 into 1. So 2 and 1. Then this of course will have to be 1, 1, that can be, and this will have to be 2, 1. There is a catch, unfortunately. For some reason, if it is completely filled with ones and the switch is being read, then 1 changes to 0. And that I don't get. Anyway, let's see how this works out. Run. And then of course I have to press. See how everything works out. And yes, I am clearly pressing it because you see the signal now. Alright, let go. And oh, this is not alright. This is alright, but this somehow isn't. Okay, wait. Oh wait, this is the older one, this is the new one. But I've made a mistake. Two rows, one column. First row, first column. Second row, first column. Ah, wait. Yes, of course. Alright. Go again. And pressing the button again. This works. Now it's diminishing, so second one is being filled, if it's alright. Okay, so let's now take a look at how things work out. This is not good at all. It is not being detected. Now here everything is good. Maybe this wire isn't. Let's see. This is 2, 3 and 4. Right, let's reinsert. And let's check again. Yeah, so run, press, So this signal should be well captured. Right. And now this is captured. This is nice. So that was a wiring issue. How to proceed? Okay, in preparation of a next idea to get this LED burn when the whole matrix is filled. With this is a plus, this is minus. So I put it in like this, and I want it to have a digital port feed it. Prior to this I tested it and it worked, and then when connecting it, it fried, completely fried the LED. So how come that 5 volts or that a port without even being programmed fries it? Well, one simple thing is that I put a probe right here and it shows 5 volts on the oscilloscope right here. So that brings the question, why is it active anyway without being programmed? So let's go here. This is port D2, D4, and the port that I just used was port 22, if I'm entirely correct. Yeah, these are all even ports. Then this is indeed 23, 25, 6 and 29. Am I missing something? Could be. Let me just take a small mirror to be sure. V2 it says, or 2. V2, and does it say here anything? V2. I'm not sure what V2 means. Is this on port 22? No, that's not port 22. That, oh wait, that's 5 volts. It just says it's 5 volts, it's not digital. So I should not have put it here, I should have put it, oh wait. So okay, let's step back. These two ports are 5 volts. So while I think that the red LED should be capable to withstand 5 volts, I should have put it into this port, which actually is port 22. However, it doesn't do a thing anymore now, and this signal will be 0. Yes. So by an unfortunate accident I lost an LED. That is too bad. But on the other hand, I need to find out why an LED, a red LED, can't have apparently 5 volts. because I have also LEDs that easily take 9 volts. So I'm very curious about that one. Okay, one more word about this fried LED. The strange thing is that I tested this one on the Visitechnic power controller, which is driven by 9 volts. Output 9 volts. Just the only thing that is variable is the pulse modulation. So if this is capable to withstand 9 volts and it is fried by 5 volts, and apparently LEDs are driven by current, then how much is that current? And that is something that leaves me wondering. So now this LED does work. I tested it again using the same power controller. Just now not 5 volts but on digital 22 actually, like I intended to. So let's see how I can put this in. This is an Octave, so I check that if S1 1 is 1 and S1 2 1 is 0, and let me put this in brackets as well. Then write digital, I think, because this is a read digital pin. Let me put it to write digital pin. AR D22. Oh, and then most likely 1. Not quite sure, but let's just do that. And closing with and if. Right, let's run. Is this? Yeah, I did a plot test, but that just did a horizontal line because all is 1. Right, let's run and see whatever happens. So this small LED should run, should show something, provided that everything is 1. That is to say, aha, it doesn't know an end. I didn't figure that one out. No, not acceptable, but this is acceptable, but apparently, oh, what I can do, maybe, is checking the whole of the matrix. If whole S1 is 1, then do it. Could be, yeah. Let's try that one. So, let's go for that. Now diminishing. Alright, now let's see whatever happens. Error, S1 undefined. Seriously. Near line 38. Oh yeah, sure. It was, yeah, I made it capital and it's small print. So I can start all over again. And oh, wait a minute. Yeah, this one was registered, so that was alright. Press run. That, yeah, it does run. And then it'd be nice if I saw everything. Then the while loop, which brings the speed down again, or the pulse width modulation. Yes. So let's see whatever happens. I did. Oh wait, yeah, that's a point. I have to mind this LED. But on the other hand, it's not okay. So it wouldn't have burned anyway. Because the condition is if S1 is 1, whole of S1. So if S2 2, 1, which is row 2, column 1, is 0, all of S1 is not 1. So the question is, why? Why is apparently this signal not always received well? I don't like that, and I don't get it. Alright, new effort. Two things. First, if the whole of S1 is 1, then write to digital pin D22 is 1, and then I added display D22 is LED to the command window. But as shown previously, then when the first element is 1 and it is read again, it is changed into 0, which is, to my opinion, strange. But what I've done now is to notify that if digital read is 1 and the first element already is 1, then S2 becomes 1. And I'm very curious what the result will be. So with this, let's run and see whatever happens. So pressing the button and taking a look at this very small LED. There's nothing happening. What is wrong? Ah, I made a mistake. Yep, typo. Should be double. It's an if statement, then this has to be double. Right. Next attempt. And of course pressing. Now it works. Getting larger and getting 0 again. and all we have to do actually is watch it here. Okay, now let's see whatever the command is. Okay, wait. So, starting 0 0, that's alright. Then 1 0. No, hold on. 1 0. 2 0 is not okay. Between again. MATLAB short circuit operation. And then this is not okay, probably because I released the switch. Why is this not alright? It's a Boolean operation, and according to the documentation that has to be an ampersand for bitwise operation. Element, oh wait. Wait a second, I'm making a syncing mistake. It's not an element, it's not a Boolean operation in per se. It has to be an element-wise operation. Because I am now comparing digital input with the element of a matrix. And I'm not even sure that that works. That's a very good point. So, if this is alright, element-wise, and this is right, then this part is wrong. Oops, didn't think about that one. But apart from that, it still didn't read again this part. So the read digital was 0, despite me holding on to the button. So should I replace the button? That's a good question and I don't know yet. And to finish off, by lack of time, I have to add port 22. So let's bring this down a bit. Alright. Let's go on. Yep, that's okay. Then copy and make this 22. Add an LED. No. What's happening here? This one. And adding nicely to ground, whereas this becomes, no, this one becomes LED 3. Alright. More to do? Not yet. So. And that really is it for now. So, still some mysteries on why pressing the button and the signal isn't caught or captured, then the mystery of an LED that is fried on 5 volts while it easily takes 9 volts. Very strange. I may have put it in wrongly, but I doubt that, because I really did test it and it did work for a short moment in here. Then of course the point that reading in a digital value doesn't make it an element, and in Octave things must be an element, so I have to find a solution for that one as well. Which brings me to say thank you for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, very much appreciated. You can follow me also on Instagram and Twitter, and I also appreciate it if you make a small donation. You can also choose to become a patron and have your name mentioned on my website, or depending on your pledge, also with the videos. This is going to be continued. Have a nice day and bye bye.